Hello students, today I am delivering the lecture about the depletion type of MOSFETs. So in depletion type of MOSFET we have basically shows the difference between the enhancement type of MOSFET. So in this basically first major difference when we compare it towards the enhancement type of MOSFET. In enhancement type of MOSFET basically there no exists the channel between the drain and source. Physically not exist. But when we talk about the depletion type of MOSFET, there is exist a channel between the that is called the inversion channel that is exist between the drain and source underneath the gate of the gate terminal between the drain and source over the substrate. So in this case I will explain here the N channel depletion type of MOSFETs and P channel different type of MOSFETs. So in N channel of MOSFETs I will explain here that basically the when we use the N channel, so our drain and source are major majority carriers that are the heavily doped N channels or heavily doped N type materials. That is basically the source and drain terminals. And the channel is exist, that is the majority of the electrons are present there when we talk about the N channel device. And the gate is basically the aluminum contacts. Here we'll explain here the P channel. So in case of P channel, basically the majority carriers are the holes. So in this case, heavily doped P-type regions are present there. And in this case, we adjoin the drain terminals towards the negative terminal and source is already caught towards the ground. And depends on this controlling voltage that is called the gate voltage. When we applied the positive voltage or a negative voltage, the current control condition depends flows between the drain and source terminal depend on this particular gate voltage. So according to that, in depletion type of MOSFET, depleted means depletion of the carriers from the channel towards the substrate. That depends on the particular gate voltage what we have applied. But the major advantage of this depletion type of MOSFET is present there, that we have use the particular gate to source or nearly equal to 0. But when we increase the negative voltage, then reduces the drain current, and we increase the positive gate to voltage, then enhances the gate current. So depletion type of MOSFET, basically two types of characteristics are present there. That depends on the particular gate to voltage. When we increase the voltage, it is work as an enhancement type of MOSFET, and when we decrease the decrease the gate voltage, that is work as an depletion type of MOSFETs. So in this case, first I will explain here the working condition. So here I will show the basically the structure here where we use the effect of potential on the free electrons, and that is basically the diagram where I will show here the drain terminal is connected towards the positive terminal of the battery and the negative terminal towards the ground. And when we applied the gate voltage towards the gate terminal, and here will shows the drain terminals are basically the heavily doped N channel, heavily doped N regions, and between them exists a N channel, that is basically the majority carriers are the electrons are present there over the different type of substrate that is called the P type of substrate, that is opposite, that depends on the opposite condition of the particular channel condition. Our channel is N channel, so our substrate is the P type, or suppose our channel is P type, then it is a condition of N type. Drain and source voltage, when we use the P channel, then opposite of the particular condition, from drain is connected to negative side and gate is also connected towards the requirement condition what we have achieved. We have required the negative voltage, we have required the positive voltage, that depends on the particular thing. Here we will consider the circuit where we use the voltage here conditions, that is the working principle. Here we use the connect the drain terminal towards the positive side. When we applied the negative voltage towards the gate terminal, so according to this particular voltage, when we use the negative towards the voltage, then basically when we applied the negative voltage, then electrons are present in the channel, it is attracted towards the gate terminal, so increases in the channel. But at the same time, holes are also present in there, but in less numbers. When we applied the negative voltage in more condition, then negative depleted. So electrons are away from this channel and p-type substrate, magic carriers are the holes are present there, and it are attracted towards the gate terminal. So basically the channel, when we applied the negative voltage, so in the channel basically the void of electrons and basically attract of the holes towards the gate terminal in the channel. So basically we have said here recombination processes occurs, but when we talk about the particular creativity of the channel depends on this particular carriers. So according to that, when we applied the negative voltage towards the gate terminal, basically depleted the electrons from the channel and attract the holes from p-type substrate towards the channel. So in the channel basically drain current reduces because the drain current depends on the particular electron values which is less in number in the channel. When we increase the drain current according to application of the drain to source voltage, then the electrons flow is started from the source to drain and drain current is started from drain to source terminal. But due to the less of the electrons are present there when we applied the negative voltage at the gate terminal, so drain current is reduces. I will show here in the graph of this characteristics. Here first one is the gate voltage is equal to 0, but when we increase this particular voltage -1 -2, so according to when we increase this particular negative voltage, so the less value of the voltage, less value of the electrons, drain current is reduces. So I will explain here the drain current is reduces when we applied the gate voltage towards the negative way. At the same time, suppose I will explain here, suppose I will apply here the positive voltage towards the gate terminal. Suppose when we applied the positive voltage toward the gate terminal, so according to that, when we applied the positive voltage, electrons are negative charge, they attract towards the gate terminal and required manner, sufficient majority way that is created between the underneath of the gate and between the sales and drone in majority terms. And magnetic electrons are also magnetic holes are all present there, but due to the application of the positive voltage is just opposite, so these are the away from the particular channel. But due to the application of the positive voltage, magnetic carriers are electrons and in many numbers, so it is supportive manner. So when according to when we increase the drain to source voltage and we also increase the gate to source voltage, so as a less when we increase the plus 1 volt, plus 2, plus 3 volt, so very less number we have increased the drain to source voltage, according to we have enhances the drain current, so it is work as an enhancement mode. So according to the application of the voltage value, we have worked the depletion type of MOSFET in a particular depleted mode on an enhancement mode. That depends on the particular majority carriers of the electrons, that is in enhancement number on in decreasing number, that depends on the particular application of the gate voltage towards the gate to source terminal. And the next slide, in this same way I will also explain here the transfer characteristics. So in the transfer characteristics, when we from increasing from 0 to 5 volt, 10 volt, 15 volt in forward bias condition, that depends on the particular positive voltage, drain current enhances, so it is work in enhancement type MOSFETs. When we increase the drain to source current, drain current is increases. But when we applied the negative voltage, that shows by -5, -10, -15, -20. So when we increase the negative voltage, our drain current is reduces. At -15, that is drain current is nearly equal to 0. So that graph transfer characteristics shows the n channel enhancement or depletion type of MOSFETs. In this case, basically when that is also shown by the relation that is called the Shockley's relation. In this Shockley's relation, ID is equal to IDSS 1 minus VGS upon VGS of the whole square. So in this case, basically when the drain to get to source voltage is nearly equal to 0, that is a particular point. When the drain to source voltage is 0, so Drain current is also reduced when we put the VGS value 0. So ID is equal to IDSS. That denotes by this particular relation ID is equal to IDSS when the gate to source voltage is nearly equal to 0. So that is shows by this Stokes equation. So in this case, basically the drain to source saturation current VGS equal to 0. Understand when we put the VGS equal to 0, ID is equal to IDSS, that equal drain to source saturation current. And the same way when we consider the P type of channel, so just graph is reverse, enhances towards the VDS positive and depleted towards the negative voltage. So that is the basically the graph of the P type channel. And basically all these things are dependent on the Stokes equation, that is denoted by ID is equal to IDSS 1 minus VGS upon VGS whole square. But our drain current is basically depend on the different type of drain to source voltage and gate to source voltage, because ID is the function of VGS and VDS both. So it is dependent on different type of things. First I will explain here the distance between the source and drain, that is called the channel length. Next, channel width, because channel width is decided the in what intensity carriers are present there. Because the intensity is high, that at a less drain to source voltage, less drain gate to source voltage, drain to source voltage, at a less gate to source voltage, current is increases at a less drain to source voltage. So depend on the channel width, it is dependent on the less value of voltage required to enhance the drain current. Next one is threshold voltage. So threshold voltage is dependent upon is when we require the threshold voltage to enhance this drain current. The thickness of the gate oxide layer. What is the thickness of the gate oxide layer? What is the dielectric constant of the gate insulating material? What is the current mobility, that is electrons or holes, because the electrons mobility is greater than the hole mobility, so drain current improvement is also occur. So these things are depend on the particular values. Here we will explain here the different type of symbols are present there. Here the three terminals are the gate, drain and source, but the fourth terminal, that is called the body, also called substrate. So here the four terminals are present there. First one is N channel and next one is P channel. So next natural source arrow of the source from source to gate, and in P channel from gate to source. That is basically the next one is simplified diagram, that is generally shows the gate, drain and source. And for different type of, when we talk about the enhancement type of MOSFETs, these are the examples of the depleted type of MOSFETs. But when I take about the examples of the enhancement type of MOSFETs, in this case the N channel and P channel symbols are present there. This type of manner we have present the different type of terminals according to symbols diagrams. That is basically the shows here. So and next, when we talk about the CMOS devices, CMOS inverter, I will explain here. When we attach the gate terminals towards the input voltage and source gate drain and drain gate source, and we have taking a common terminal from the output voltage and we applied the input voltage and just the output voltage, that is use the reverse manner, means inverter means when we provide the 0 voltage then convert it to 1, and we provide the 1 voltage, that is converted into 0. That is shows basically the table 0 to 1, 0 input output 1, when we apply the 1 input output 0, that is shows the inverter condition. So in this case I will explain that the supply voltage, we have attached here the upper source terminal towards the VDD terminal, that is called the upper P channel MOSFET, enhancement type of MOSFET, and below this we have attached the N channel type of MOSFET, enhancement type. So source gate drain gate source, we have provided the input terminals towards the both terminals of MOS and NMOS attached and towards the input gate terminal, and we take the output terminals from the drain of the two transistors. So according to that, basically the switching properties according to that, because we have known here that the PMOS is required to turn in a very less voltage when we provide the 0 voltage. When we provide the 0 voltage under that condition, upper voltage, that is basically the upper transistor, that is basically the Q2, that is P channel type of enhancement type of MOSFET, and below N channel enhancement type of ON, that is denoted by Q1. When we given input, that is basically the 0, P channel enhancement type of MOSFET is on and N channel enhancement type of MOSFET is off. So in this case it is acts like a switch. Q2 is on. When Q2 is on, VDD is directly connected towards the output voltage. So according, output is high. When we provide the 0 voltage, so output is high. And when we give the input voltage, that is basically the 1 voltage nearly equal to VDD, maximum supply voltage. So in this case, P transistor is off condition and N transistor is an on condition. So upper transistor is an off condition, lower transistor is on condition. So output is acted towards the down terminal. When we provide the high voltage, VDD voltage, but the output is nearly equal to 0, but it is the ground voltage. So according to that, when we increase the voltage towards the VDD, then output is nearly equal to 0. So it is work as an different type of logically conditions. How can it is work as a CMOS inverter? Means we have provided the input voltage 0, then we increase the output voltage in output, that's equal to 1 VDD voltage, and we provide the input voltage VDD, then it is output equal to 0. So that is basically the condition that depends on the switching conditions, switching logics, that depends on the particular input voltage, which type of transistor which is on condition is an off condition, and which way it is connected towards the output, that depends on the input voltage. And we have provide the 0, then output in 1, and we provide the 1 input, output is 0. So it is work like a CMOS inverter that depends on different type of logic swings, and we have generated the output voltage according to that. Thank you.